Hello everyone, welcome to the Makri Virtual. Hope you are doing good. Today I'm going to continue with the same module, that is a procedural programming module. And in the last class we have covered the chapter number 18, that is we have continued with the chapter number 18, that is graphics under the Windows. We have covered few topics like device context, a closer look, and then in the today's class I'm going to start with the same continuation of this one, that is the device context, how to do the Windows programming, what is the use of the WM create function, event handler. So let's start with the session. Let's start with the previous session, that is the last class session. So in the last class we have started with the device context, that is how to use the device context, or what is the device context in this one. So device context is nothing but a structure that holds handles of various drawing objects, that is used to get, or that holds handles of the various drawing objects like phone, pen, brush, etc. So DC is a structure that holds or that handles the drawing objects or various drawing objects. So it is like a supervisor of the drawing objects like phone, pen, brush, that is a drawing object that is available in this one. A screen DC and its working is shown in figure 18.6. This is what we have discussed. There are so sorry. There are two applications, application 1, application 2. There are two drawing objects, one is aerial, one is red pen, one is blue brush, and there is one screen, that is the output device. So there are two applications, one is application 1 and application 2. This is a black pen, white brush. So this is what we have discussed, that these are the default drawing objects that is available, and these are the two applications, that is application 1 and application 2, and there is only one screen that is shared by both these applications. You can make the following observation from figure 18.6. What are the observations? That is, the DC does not hold the drawing objects like pen, brush, etc. It merely holds their handles. That is, it does not hold the drawing objects, that is, it only handles the structure of these, that is pens, that is brushes, etc. With each DC, a default monochrome bitmap of size 1 pixel x 1 pixel, that is 1 into 1 pixel, is associated with the each DC. That is, with each DC, a default 1 by 1 pixel is associated with the each and every term, that is pen, brush. Then default objects like black pen, white brush, this is a black pen, this is a white brush, are shared by different DCs in same or different applications. So this is shared by different DCs like application 1, application 2, screen DC, are shared by different DCs in same or different applications. The drawing objects that an application explicitly creates can be shared within the DC. So these are the various terms, these are the various observations that we have discussed about this example, this topic, this scenario, this figure, right? Then this is screen and the printer DC is okay, but what purpose would a memory DC serves? This is what the next program would explain. That is, what is the purpose of the memory DC, or what is the purpose of memory DC? I agree with the screen DC, I agree with the printer DC, because printer DC is used for the printer and the screen DC is used for the screen. But what is the purpose of the memory DC? Now, displaying a image or displaying a bitmap, that is how to display a bitmap, how to display a bitmap using the device context. This says we are familiar with drawing normal shapes on screen using a device context. How about drawing images on the screen? Windows does not permit displaying a bitmap image directly using a screen DC. This is because there might be color variations in the screen on which the bitmap was created and the screen on which it is being displayed. To account for such possibilities, while displaying a bitmap, Windows uses different mechanisms. What is a different mechanism? That is a memory DC. So whenever we have to draw, or whenever we want to draw an image on the screen, that is done by displaying a bitmap, that is done by a different mechanism, that is done by the memory DC. So memory DC is used for displaying an image on the screen. The way anything drawn using a screen DC goes to screen. Anything drawn using a printer DC goes to a printer. Similarly, anything drawn using a memory DC goes to the RAM. So this is the scenario. So whenever there is a condition, whenever we use the memory DC, so every content, everything that is related to memory, that is going into the memory, that is a RAM. But where in the RAM? That is in the 1 by 1 pixel bitmap whose handle is present in the memory DC. This is what we have discussed. This is the next one that we have discussed, that this is the default memory DC. There are the default brushes, there are the default pen, bitmap, font. This is for black pen, white brush, font, default output device. And this is the memory DC after selecting the bitmap. That is, this default output device is converted into the new one, that is as per my capacity, as per my selection, that is a select bitmap. This is for 40,000. This is the color bitmap. What purpose would just increasing the bitmap size color would serve? Whatever we draw here, we could get drawn on the bitmap, but would still not be visible. That is, or we can make the visible, or we can make it visible by simply copying the bitmap image. That is done by the API function, that is a bitBLT. So this bitBLT function is used. This is the API function that is used for displaying the bitmap color, or displaying the bitmap image. Now then we have discussed about the program, or that what is the program, how we are using the program. This is the same program, that is how to display the bitmap, how to display this eagle. And this is the explanation of this one that we have studied, that what is the use of onPaint function, that begins with the begin paint function, then use the load bitmap, create compatible BC, that is used to make the screen DC that is available under the Windows. Then bitBLT function, this is the bitBLT function. As a result of this, the virtual now appears in the window. We have made the call to the bitBLT function as shown below. This is the bitBLT function. There is a HDC, then 10, 20, 190, 220, H memory DC 00, SCR or SRC copy. Now let us understand its parameter. That is, what are the parameters that is available in this one, that is HDC 10, 20, 190, 220. First of all, there is a HDC that is able to handle to the target DC where the bitmap is to be blatted. Then 1020, the position where the bitmap is to be blatted. Then 190, 220, that is the width and the height of the bitmap being blatted. Then this is a 00, that is the top left corner of the source image. So if we give 1020, then the image from the 1020 to bottom right corner of the bitmap would get blatted. Then next one is your SRC copy, that is how to use the SRC copy, that is specifies the raster operation codes. Then we have also discussed that how to use the animation at the work, how to do the animation under the windows so that there is a movement, or how we can add the movement and sound on the windows. So if we are to animate an object in the window, we need to carry out the following steps. What are the steps that is available under the windows? Note that the width and the height of the red color ball is 22 pixels. This is the program, this is the function that is given below, that is the WND procedure function, that is the WND Windows procedure function. These are the variable that is declared. One is the HBMP, then HMemoryDC, hold BMP. These are the function, or this is the function that is available. There is the switch case, then that is the message. There are different cases. What are the different cases? One is for the destroy, one is for the WM create, one is for the timer. In the today's class, I am going to continue with the same topic, that is WM create in detail. That is how to use the WM create. This is a function that we have discussed, how we are using the on destroy function, on timer function. Now This says from the WND procedure function, that is the window procedure function, you observe that you have handled two new messages. What are the two new messages? That is WM create function and WM timer function. So these are the new two functions that is available. One is create, one is timer. For these messages we have called the handlers, that is on create function and the on timer function. These are the two functions that is available. One is the on create function, one is the on timer function. Now let us understand these handles or handlers one by one. First one is your WM create function. That is, now let's start with the today's session. That is WM create function and the on create function. This is the first part, that is the WM create, and the function that is used for the WM create is on create function. So these are the two messages. One is WM create, one is the WM timer. For these messages we have the handlers, we have the structure that is available. One is the on create function, one is the on timer function. So these are the two functions that is available for these two new messages. One is the WM create, one is the WM timer, and the function name for these one on create function and the on timer function respectively. The WM create message arrives whenever a new window is created. So whenever there is a requirement of the WM create function, or whenever a WM create function arrives, or this is a function, this is a message that arrives whenever a new window is created. So whenever a new window is created, a new message arrives, that is a WM create function. Since usually a window is created only once, the one-time activity that is to be carried out in a program is usually done in on create handler function. This says since a window is created at least or only once in a time, the one-time activity that is available, that is carried out in a program, is done in the on create handler. So this is the on create handler that is available for fetching the messages, for getting the messages that is arrives or that arrives in the WM create message function. In our program, to make the ball move, we need to display it at a different places at the different times. So as per my example, the example is to rotate the ball. So that is carried out in a program by using the on create function handler. In our program, to make the ball move, we need to display it at different places at different times. To do this, it would be necessary to blit the ball image several times. Blit means to make this ball visible at the different times. To do this, however, we need to load the image only once. As this is a one-time activity, it has been done in the handler function, that is the on create function. So our example shows that how to use the, or how to do the messages, or how to use the function that is available under the Windows. So however, we need to load the image only once. As this is a one-time activity, we use the function on create function. So you are already familiar with the steps that is involved in preparing the image for blitting, loading the bitmap. So these are the various steps that is available. What are the steps available? So first, whenever we want to blit the image, first of all, load the bitmap. That is, first of all, load the image, then create a memory DC. That is, then approach or then load the image into the memory DC. That is, transfer this into the memory DC. Okay, Larry, just a minute. Now, are you able to hear me, Larry? Hello? Now it's okay? Okay, thanks. So whenever there is a steps or whenever there is a need for blitting the image, that is whenever there is need that we want to blit the image, that is done by the various steps. What are the steps available? First of all, load the bitmap, that is load the bitmap into the memory, then create a memory DC, again loading the bitmap into the memory, making it compatible with the screen DC, that is make them compatible with the screen DC, and select the bitmap in the memory DC. Then selecting the bitmap into the memory DC. Apart from preparing the image for bleeding, we have also done some initialization, like setting up the values in some variable to indicate the initial position of the ball. That is, apart from preparing the image for bleeding, that is, apart from bleeding, there are so other initialization that is also available, like setting up the values, initializing the values in the variables, in some variable to indicate the initial position or the lower position of the ball. We have also called the set timer function. So first of all, bleed the function for creating or for handling the messages. Then there is another function that is available that is used to move the ball in a various places, that is used to bleed the, or that is used to set up the values in variables, that is for indicating the initial position of the ball. We have created this, or we have done this, or we have to do this by using the set timer function. So this is the function that is available that is used to call the set timer function. This function tells Windows to post a message, that is a WM timer, into the message queue of our application every 50 milliseconds. That is, within every 50 milliseconds this message arrives, or this is the message that is used, that is a WM timer function, and this message is handled by using the handler, that is a set timer function. So this is the set timer function that is available, and the message name is WM timer message, and this is available within every 50 milliseconds, or it would appear within every 50 milliseconds. Now, what is the use of WM timer and the on timer function? This we have already discussed in this paragraph. Now, what is the use of WM timer and the on timer function? So, if we are to perform an activity at regular intervals, we have two choices. That is, if we are able to perform an activity at a regular intervals, there are two choices. What are the two choices? Use a loop and monitor within the loop. That is, first of all, use the loop and monitor within the loop when it is, or when is it time to perform that activity. That is, perform an operation, perform an looping, and monitor within the loop that it is a time to perform these activity, or it is a time to perform that activity. Use a window mechanism of timer. That is, next point says use a window mechanism, that is, use a follow-up or use a timer for the window mechanism. This mechanism, when used, post a WM timer message at regular intervals to our application. That is, this mechanism is used whenever we use, or whenever we use the post a WM timer message at regular intervals to our application. The first method would seriously hamper the responsiveness of the program. That is, this is the first method that is available. Simply uses the loop, and at times there are, for example, 5 times a loop will execute. Then monitor within the loop when it is a time to perform that activity. So that means that is like a round robin method. That is, whenever there is a limit, or whenever there is a turn, that loop will terminate, and it is a time to perform the activity at that time only. This would hamper the responsiveness of the program. If the control is within the loop and a new message arrives, the message would not get processed. That is, if there is a time set for the each processes, and in between, for example, a new process arrives, that process goes waste. Why? Because in case of looping, so whenever the turn comes, that then and only then this loop will execute, or this message will execute. But what happens when the message would not get processed, or what happens when the new message arrives? That would not get processed unless the control goes out of the loop. So these are the two choices that is available. So first one is not effective. Why? Because it depends on the looping. It depends on the looping, or it depends on the turn-wise game. So second choice is better. Why? Because it makes the program event driven. So it makes the program. What is the second message? That is, uses a window mechanism. This mechanism, when used, posts a WM timer message at regular interval to our application. So second choice is better one. Why? Because it makes the program event driven. That is, whenever the WM timer arrives, at that time it handle or its handler, that is the on timer function, does the job that we want to get executed periodically. At other times, the application is free to handle other messages that come to its queue. That means if there is a message, that handler does the job that we want to get executed on a periodical basis. At other times, at the other places, at the other times, it would or the application is free to handle the other messages that comes into the queue. All that what we have done in the on timer handler is the erase the ball from the previous position and draw it in a new position. So either we can use first function or first method, or either we can use second method. But as per the opinion, as per the responsiveness, the second one method is better one, right? So all that what we have done is the on timer function handler to erase the ball from the this one. If so, we have played a sound file using the play sound API function. If we done so, we have used a new file that is done by the API function, that is a application programming interface function, and then change the direction of the ball. A few more points, that is, what are the few more points that is available? A few more points worth noting before we close our discussion on the animation. That is, these are the few important points that is available before we close the animation part, that is how to move the procedure, what is the on timer function, what is the on create function, what is the use of WM create message, what is the use of WM timer message. So the first point says one application can set up multiple timers to do a different jobs at different interval. That is, there is only one application that can be used or that can set up multiple timers. Multiple timers means multiple time zones that is used to do a different jobs at different intervals. That is, there is only one application that can be used or that can set up multiple timers or multiple time zones to do a different jobs at different intervals. That is, there are different jobs at different interval that is available, that is used to get the application, that is used to get the different timers on one application. Hence, we need to pass the ID of the timer that we want to set up to the set timer function. In this case, there is a requirement to set up the timing or to place the timing or to pass the ID of the timer. In our case, we have specified the ID as a 1. That is, this is the example that we have specified the timing as a or ID as a 1 of the timer. For multiple timers, suppose in a queue in an application there are multiple timers, that is, there are multiple timers that is available. In that case, Windows would post multiple WM timer messages. So there are, if there is a condition, if there is a scenario that there is a multiple timer that is available, so in that case Windows would post the multiple WM timer messages. Each time it would pass the timer ID as an additional information about the message. So every time it would pass the a timer ID as a additional information including with the message. For drawing as well as erasing the ball, we have used the same function, that is the bit BLT function. That is the third point. That is, whenever we want to draw and whenever we want to close the ball, erase the ball, not close, erase the ball, we have used the same function. What is the name of the function? That is a bit BLT function. So it is saying, while erasing, we have used the raster operation code, that is the whiteness, that is used for giving the white to the BLT or BLT. When we use this code, the color value of the source pixel get ignored. Because there is a whitenessness, so the color value is ignored. Therefore, the red color pixel would get ignored, leading to the eraser of the ball in the window. Then the fourth point says, then the D point, that is the fourth point says, the size of the client area of the window can be obtained using the getClientRectangle API function. This is the function that is available that is the size of the client area that is available can be obtained. For example, if there is a need that I want that what is the size of the area or what is the size of the window that is available, that we can achieve this by using the function that is also a API function, that is a get client rectangle function or get client rect function. We want that every time we run the application, the initial position of the ball should be different. So if there is a case that every time we run the application, the initial position of the ball should be different. That is, initial value or the initial position where the ball will rotate is different in every case. For example, this is my requirement. To ensure this, we have generated its initial XY coordinates. That is, for doing this, we have generated its initial XY coordinates using the standard library function, that is a rad function, that is a random function. However, this function does not generate true random numbers. To ensure that we do not or we do get a true random number, somehow we need to tie the random number generation with time, as time of each execution of our program would be different. This has been achieved by making the call, that is the srand time null. So this is the function that is used, that is the srandom function, and the time, then there is a null. Here time is a function that returns the time, and srand is the function. So in simple terms, this time has been passed to the function that is the srandom function. Next point says, to be able to use rand and the srand functions, these are available in the std library.h. So these are the functions that is available in the header files. What is the name of the header file? That is the rand function and the srand function. One is the random function, one is the srandom function. Similarly, for time function to work, include the file that is a time.h. In the call to the play sound function, so this is the play sound function that is used. The first parameter is the name of the wave file. That is the first parameter that is used, that is the name of the wave file that is to be played. If the first parameter is the file name, then the second has to be null. So if I am using the play sound, the first parameter that is used, that is played, or that is used, that is the parameter that is used, then the second has to be null. So if this is the first parameter, the second must be of null. The third parameter is the set of the flags. SND file name indicates that the first parameter is the file name, whereas SND async indicates that the sound should be played in the background. One is the file name, one is the async, that is the asynchronous. Next point says, to be able to use the play sound function, we need to link the library function, that is a winmm.library. So whenever there is a requirement to play the or use the play sound function, so we use the one more library. We want to merge the library, that is a winmm.library. This is also a function that is available in case of the play sound. This is done by using the project settings menu items. Now the last one is, whenever the application terminates, we have to instruct the Windows not to send the WM timer messages to our application anymore. That is, if there is a termination of the window, so there is no requirement for the, or there is no requirement that we send the set timer function again. So we instruct the Windows not to send the WM timer function or the on timer WM timer message on the on timer function that is available. For this, we have called the function that is a kill timer function. So this kill timer is used for killing the timing. API function that is passed to the ID of the timer. Next is Windows, the endless word. That is Windows, the endless word of the window. The biggest hurdle in Windows programming is a second understanding of its programming model. In this chapter and in the last two, I have tried to catch the essence of the Windows event-driven model programming. Once you've understood it thoroughly, rest is just a matter of understanding and calling the API function. So this is the that's the um, theory that what we have covered, what we have achieved in the graphics under the window. That is how to use the graphics under the Windows. Windows API is truly an endless word. It covers areas like networking. So whenever we use the Windows application programming interface, so it is a large coverage area. We can also use the networking in this. We can also use the internet programming, that is TCP/IP, telephony, drawing, printing, device input output, imaging, messages or messaging, multimedia, windowing, database programming, shell programming, to name a few. The programs that we have written have merely stretched the surface. No matter how many programs that we write under Windows, several systems remains to be written. The intention along was not to catch fish for you, but to show how to catch fish and so on. So this chapter, this paragraph, it is saying we have covered each and every API function that is used to link, that is used to draw, that is used to make the or give the multimedia elements, database programming, shell programming, etc. So this is the ending up of the chapter. Now let's see the summary. That is the summary of this chapter. That is what we have covered in this chapter. The first point is, there are multiple points of this. That is the summary. This says in DOS programming, in DOS the programmer have to write separate graphic code for every new video adapter. So whenever there is a requirement or whenever there is a any new video adapter that is available in DOS programming, so programmer have to write different code for the different new video adapter. But in Windows, the only one code is used on any video adapter. That is, if there are multiple processes, if there are multiple codes, or if there are multiple video adapter that is available, the same code is used. A Windows program cannot draw directly on an output device. That it cannot draw directly on an output device like screen or printer. Instead, it draws to a or to the logical display surface using device context that is available. So whenever we use a Windows, it cannot draw directly on an output device like screen or printer. Instead, it draws to the logical display surface using the device context. That is what we have studied. Next point says, when the window is displayed for the first time, that is when the window is used for the first time, or it is displayed for the first time, or when it is resized or moved, only the one function is used, that is only the one handler is used, that is the onPaint function. So this is the onPaint function that is used whenever we when the window is displayed for the first time. Then D point says it is necessary to obtain the device context before drawing text or graphics in the client area. It is necessary to obtain the device context whenever we want to draw the text and the graphics in the client area. Then next point says a device context is a structure containing information that is required to draw on a display surface. The information includes colors of pens, brush, screen resolution, color palette, etc. To draw using a pen or brush, it is necessary to select them into the device context. So whenever there is a requirement for drawing using a new brush or the new pen, so it is necessary to select them into the device context. Next point, if we don't select any brush or pen into the device context, that is, if we have not selected any brush, any drawing in the client area, then the drawing that is drawn in the client area would be drawn with the default pen. That is, if we have not selected anything, so the default pen that is available, that is a black pen, and the white brush is used for printing. So there is a black pen and there is a white brush. Then next point says RGB, that is your red, green, blue, is a macro representing the or it is a macro that is available in the programming that represents or that stands for red, green and blue. If we are giving an argument like 000, that gives only the black color, because there is no red, there is no green, there is no blue. And if it is available 255, 255, 255, that means red is also 255, green is also 255, blue is also 255. That simply gives the white. So whenever there is a less value, that is the last value, that is 0, that gives the black color. And whenever there is a largest value, that is a 255, that it gives only the white color. In case of 3 or all the 3 values, that is the red, green and the blue. Last point says animation involves repeatedly drawing the same image at successive positions. That is, we can repeat repeatedly, we can draw the same image at the different positions. We can make, or we can show you how to move the images, how to draw the images, how to rotate the images. Then there is an exercise. So this is the winding of the chapter. That is, this is available. This is the chapter that is available. Right. So that's all for today. Sorry, that's all for this chapter, not for today's session. Only for this chapter. This is the exercise. This is the true/false question. This is the lengthy short type questions. This is the programmatical questions. Now there is a next chapter, that is your 19th chapter, that is interaction with the hardware. That is how to interact with the hardware. That is the next chapter. So first of all, let's take a break and then move to this chapter, that is chapter number 19, that is interaction with the hardware. So first of all, let's take a break only for 5 to maximum 10 minutes, but not more than 10 minutes. So it is 5 to 7 minutes break. And so come back from the break, then start with this chapter, that is interaction with the hardware. So let's take a break. So come back from the break. Let's move to the next topic, that is next chapter, that is interaction with the hardware. That is how to interact with the hardware. That is the next topic, that is chapter number 19. So we have finished with chapter number 18, that is how to use the graphics under the Windows. Now this is chapter number 19, that is how to interact with the hardware. So how we are able to interact with the hardware, that is in this chapter, that is this one. So the name of the chapter is interaction with the hardware. That is how the user is able to handle, or how the user is able to interact with the hardware in this one. Right. So there are multiple topics in this. The first one is like hardware interaction. Then hardware interaction on the basis of the DOS. That is on the basis of DOS. It is from the DOS perspective. That is how to handle or how to interact with the hardware. That is hardware interaction including the DOS perspective. Then next one is hardware interaction including the Windows perspective. Then communication with the storage devices. That is how to communicate with the storage devices. Then what is the read sector function that is available, that is the read sector function. Then how to access other storage devices, that is how to access the storage devices that is available. Then communication with keyboard, that how to communicate with the keyboard. Then there is a dynamic linking, Windows hooks, that is what is the dynamic linking, and what the Windows hooks that is available under the Windows. Then caps locked, what is the caps lock, that is permanently locked. Then did you press it twice, that is this is the next term. Then mangling keys, that is what are the mangling keys that is available. Then there is a keylogger, then there is a where is this leading, then summary, then exercise. So these are the topics of this chapter, that is chapter number 19, that is interacting with the hardware. So now let's start. There are two types of Windows programming. That is, this first point says that there are two types of Windows programming that is available, or there are two types of Windows programmers. Those who are happy in knowing the things the way they are under Windows. That is the one, or that is the those who are happy in knowing the things, who are happy in carrying out the things the way they are under the Windows, and those who wish to know why the things are way they are. That is, there are two types of Windows programmer. One, you told them that these are the things, they are simply kept it that yeah, these are the things, they are mug up that in knowing the things what they are under the Windows. And some programmers are those that they won't why this happens, why this occurs. So there is a capability of asking something that why this happens, and one is yeah, it's happened, then it's okay, nothing. So there are two types of Windows programmers. This chapter is for the second breed of programmers. That is, what is the second breed? Those who wish to know why the things are the way they are. That is the next, or that is the next part. That is this chapter is based on the this one. Why things are going this one? Why things are going this one? They are the real power user of the Windows. Because of because it is they who first understand the default working of the different mechanism that Windows uses, and then are able to make those programming windows or work to their advantage. The focus here would be restricted to the mechanism that are involved in the interaction with the hardware under the Windows world. That is, the focus here is on the mechanism that are involved in the interaction, that is how to deal with the, or how to involve with the mechanism, or how to interact with interact with the, or interact with the hardware that is under the Windows world. Read on, and I am sure you would be on your path to become a powerful Windows programmer. That is, this is for the programmers who have a curiosity, to find why this happens, why this occurs. So this is for the second breed of programmers. Now, what do you mean by hardware interaction? The first question arises that what do you mean by the hardware interaction, or what is hardware interaction? So this says primarily interaction with hardware suggests interaction with peripheral devices. That means primarily whenever there is an interaction with the hardware, that introduces or that suggests interaction with the peripheral devices. However, its reach is not limited to interaction with the peripherals. That is, its reach is not visible, is not limited to the how to interact with the peripherals. The interaction may also involve communicating with chips present on the motherboard. That is, simply whenever we talk about the interaction, suppose we interact with each other, that is, we communicate with each other. So this says primarily interaction with hardware. It is not with the within the persons, it is with the hardware that involves, or that suggests interaction with the peripheral devices. That is how to interact with the peripheral devices. Now, question arises, what is peripheral devices? So whenever we say peripheral devices, that includes both input as well as the output devices. That is, it deals with both the input as well as the output devices. So interaction with the hardware means interaction with the input and the output device, for example keyboard, mouse, motherboard, and any input device, any output device. The interaction may also involve communicating with chips present on the motherboard. That is, the communication may also involve whenever there is a chip, or whenever there is a communication with the chips that is present on the motherboard. Suppose there is a motherboard, there are 5 chips that is available. That is also interaction with the hardware. Therefore, thus, more correctly, interaction with hardware would mean interaction with any chip other than the microprocessor. Therefore, if more precisely we can say that interaction with hardware means interaction with any chip that is available, or any chip that is available other than the microprocessor. So except the microprocessor, if there is any chip available, if there is anything available, that is available or that is done by using the microprocessor. During this interaction, one or more of the following activities may be performed. That is, during this interaction that is available, one of the following activities is performed, or one of the following activities may be performed. What are the activities? First of all, reacting to the events. That is, reacting to the events that occurs before because of the user interaction with the hardware. So whenever there is a hardware interaction, whenever we interact with the hardware, so what are the activities performed? So whenever we react to the event that occurs because of the user interaction with the hardware. So there is a reaction of the events, or there is whenever there is a react of the events. So if there is an event and we react on the event that occurs because of the user interaction with the hardware. For example, if the user presses a key, suppose a user press a key or click with the mouse button, then our program may do something. That is, if the user presses a key, for example, and click on the mouse button or click with the mouse button, then our program may do something. Then reacting to events that do not need explicit user interaction. So one is these are the operations, these are the activities that is performed for the interaction. The next one is reacting to events that do not need explicit user interaction. That is, react to the events that do not need the interaction, that do not need the user interaction. Right. Now, for example, on ticking a timer, our program may want to do something. So whenever there is a timer, whenever there is a tick on the timer, my program is able to do something that is under the windows. Next point says explicit communication from a programmer without the occurrence of an event. So whenever there is a case of the event, whenever there is a case of the occurrence, so explicit communication occurs or from a program. So if there is explicit communication, that is from the program to program without the occurrence of any event. For example, a program may want to send a character to the printer. That is, if there is a program that may want, or that you want to able to print a character, that is able to send the character to a printer, or a program that may want to read or write the content of a sector from the hard disk. These are the examples that is available. There is a explicit communication, that is, there is no communication within the program, there is a communication outside the program. That is a program that may want to send the character to the printer, that is outside the program, or a program that may want to read or write the content of a sector from the hard disk. Now let us see how this interaction is done under the different platforms. This is the theory. This says what is hardware interaction? So whenever we interact with the hardware, whenever we interact with the peripheral devices, that is the input and the output devices, that is known as the hardware interaction. That is known as the interacting with the hardware, or primarily interaction with the hardware. So there are multiple activities how we can interact with the hardware. We can interact within the program, we can interact, or how we can react to the events, how we can react to the programs, how we can make the communication explicitly without the occurrence of an event. Now let us understand the hardware interaction, including different perspective, including different platforms. So one is your DOS perspective. That is, whenever there is a DOS, that is a disk operating system, how the hardware interaction achieves, how we can achieve the hardware interaction. So this says under DOS, that is disk operating system, whenever an external event like pressing a key or taking off a timer occurs. So whenever there is an external event occurs, a signal known as the hardware interrupt. This is the signal that is available, that is a hardware interrupt that gets generated. For different events, there are different interrupts. So whenever there is an external event occurs, so there is external event occurs, so there is a different interrupt, there is a different signal that is known as the hardware interrupt. And for different events, there are different interrupts that is available. I'm just coming within 2 minutes, so just take 2 minutes break. So there are different interrupts available for the different events. So this is for different events, there are different interrupts that is available. As a reaction to occurrence of an event, a table known as an event vector table is looked up. That is, for handling an interrupt, there is a table that is available, that is known as the IVT, that is interrupt vector table. IVT is present in the memory. So this is present in the RAM, that is present in the memory. It is populated or it is fed up with the addresses of the different BIOS routines during booting. So whenever there is a booting, there is a different addresses. So there is a booting, there is a difference, there is a IVT. It is populated with addresses of different BIOS routine during booting. Depending upon which interrupt has occurred, microprocessor picks up the address of the appropriate BIOS routine from the IVT. So IVT, that is the interrupt vector table, is acts like a mediator. It look up in the table. If there is a BIOS activity, approaches to the BIOS activity. If it is not available in the table, transfer to the control activity or transfer execution control to it. So this says, depending upon which interrupt has occurred, the microprocessor picks up the address of the appropriate BIOS routine from IVT and transfer the execution control to it. Once the control reaches the BIOS routine, that is once or when the control reaches to the BIOS routine, the code in the BIOS routine interact with the hardware. So there is a code that is available, that is available in the hardware, or that interacts with the hardware. Naturally, for different interrupts, different BIOS routines are called. So whenever there are different interrupts, there are different BIOS routines are called. Since these routines serves the interrupt, they are known as the interrupt service routines. So this is available or simply ISR. So ISR is a interrupt service providers or interrupt service routine that is available for the DOS perspective, that is available for the hardware interaction with the DOS perspective. This is the figure that shows how to do the DOS perspective. This is the important one. There is a hit key, there is a mouse key, or key hit, not hit key. There is a key hit. So either we can press the, or either we can hit the key, or either we can click with the mouse. Right? That generates an interrupt. So whenever there is a click with the mouse, or whenever there is a hit with the key, so both are the input and the output device. So these are known as a peripheral device. So whenever we hit the key or whenever we click with the mouse, that generates an interrupt. That goes to the microprocessor. Here there is an interrupt, here there is an interrupt, there is a microprocessor. Then microprocessor, that is the CPU or the processor, simply looks up into the IVT. That is, it looks up into the IVT, that is the interrupt vector table, the address of the ISR 1. This is available, that is the interrupt service routine. So address of the ISR 1, address of the ISR 2. That is stored in the IVT. So this is the IVT, that is this is the interrupt vector table that is available. So this is the address of first one and this is the address of second one. That is address of ISR 1 and address of ISR 2. Then suitable ISR is selected. That is, if there is a suitable ISR, that is selected in this one. So this is the IVT table that is contains both the addresses. That is the address of ISR 1, that is the internet interrupt service routine 1, interrupt service routine 2. There is a microprocessor. Then suitable ISR is called. So if there is a suitable ISR, that is called, that is if the address of ISR or if the address of ISR 2. This is the ISR 1 and this is the ISR 2. There is a BIOS routine that is available, that is the basic input output system that is available over here. Right. So this is simply show you that how we can handle the interrupts with the help of the interrupt handlers. There are keys that is available. This is from the keyboard, this is from the mouse, this is where the key is hit, and this is from where the mouse or click with the mouse. So this is hit key or key hit, mouse click generates an interrupt, goes to the microprocessor. Then microprocessor looks into the IVT. In IVT there are different addresses of ISR, ISR address 1, ISR address 2. This is address of the ISR 1, ISR 2. Then with the help of the ISR, with the help of the BIOS routine, suitable ISR is selected, that is either ISR 1, either ISR 2. If we want that instead of the default ISR, our routine should get code, then it is necessary to store the address of this routine in the IVT. That is, if my requirement is that instead of ISR, that is, instead of interrupt service routine, my routine is handled or my routine is available. So it is necessary to store the address of this routine in the IVT. So this routine that I want is stored in the IVT. Once this is done, whenever an interrupt occurs or hardware interrupt occurs, our routine address from IVT is picked up and control is transferred to our routine. For example, we may register our ISR in IVT to gain final control over the hit keys from the keyboard are tackled. This final control may involve changing codes of the keys or handling hitting of multiple keys simultaneously. So if there is an interrupt, if there is an address, if there are multiple parts that is available, that is address of ISR1, ISR2. Explicit communication with the hardware can be done in following 4 ways. So these are the following 4 ways that is available, that is able to handle, that is how to do the or how we are able to use the interaction with the hardware in the 4 different ways. So this I will covering in the next class. So let's take a practical approach in the today's class right now. So now moves to the practical approach. In the last class we have studied about the program, that is how to display the character array along with their addresses. Now my program for today's my program is simply use the character array and simply reverse the array. Suppose I have given the input, or I will give the input as a hello. So the output will be OLLEH. That is the reverse of the hello. So this is the program that shows, write a program in reverse order. First of all, there is a hash include, then there is a stdio.h, hash include, conio.h, then there is a void main, then there is a curly braces after void main, then for example I have declare one variable that is of char type that contains, for example, 15 values, right? The name of this one is s, for example. Then int I, then simply clear the screen, right? Then simply use the puts for in place of the printf, that is enter the string. Then this is the get puts, and scan, in place of scanf we have used the gets, that is for scanning into the memory. Then simply uses the puts reverse string is, then there is a semicolon. Now uses the for loop, then uses I equals to 15, that start with 15, then there is a semicolon. Then what is the scenario, that is I is less than or more than equals to 0, then there is I minus minus, that is equals to 15, that is greater than 0, then I minus minus, then uses the printf, then uses percentage %c because it is character by character, then uses the si because there are characters, that is si, then close this one. Then there is a get ch over here. Then simply closes this one. Now if I hello, if I execute this code, there is a success, there is no error. If I execute this one, enter the string. Suppose we have entered hello. The reverse string is OLLEH, that is a hello, right? If I use S, now if I compile this code, enter the string, that is hello. The reverse string is this. There are so many errors. Now if I again compile, if I entered as a this is SIHT, this is correct, that is I equals to 15, this will be declared over here. If I save this one first of all, that is a reverse string dot C. And now if I compile this code, if I enter this code as this, then SIHT, and this is a reverse string, that is after this one, right? Instead of using the for loop, can I use this one? No. So now if I compile, if I execute this code, if I give as a hello, the output is OLLEH, that is a reverse of the hello, right? Now let's see what is the function. First of all, the function is, or the program is, write a program to print the string in a reverse order. Suppose there is a string, I have to print the string in a reverse order, that is reversing the characters of the string. So first of all, two header files are used, that is hash include stdr.h and the hash include conio.h, right? Then there is a void main for the main entry gate. Then there is a char s15, that is the array is declared, that is the array name is s and it has 15 characters, right? And that is one by one character. Then there is a variable declaration, that is int I. So I is a new variable that is declared, that is of integer type. Then there is a clear screen for clearing the screen. Then there is a puts. Instead of using the printf, we have used the puts. So it is only used for displaying the content on the screen. So whenever there is a requirement for displaying the content on the screen, that is available or that is done by using the puts. So puts is used to display the content on the screen. So there is a puts, then in the bracket there is a enter the string. Then there is a gets function. It is like a scanf. The scanf is used to scan into the memory, that is stored into the memory whatever the input we have given, so that it is saved for the next time also iteration. So in the same way, in place of scanf we have used the function that is a gets. So there is a gets s. Then there is a puts, that is simply used for printf, that is a reverse string is, that is the reverse string is, that is a reverse of the string that contains or that is used with the for loop, that is for I equals to 15, I is greater than equals to 0. So it starts with 15, it goes to the 0. So it starts with the 15. So first of all 15, then 14, then 13, 12, 11 and so on till 0. Then I minus minus. Then printf, simply used for printing the values. Then there is a percentage %c, there is a s, there is a I, that is si. Then if I remove this brackets, now let's see what happened. If I enter the string as hello, this will be printed over here. So instead I will use this one. So let's dry run. So first of all it is 15. Check the condition. 15 is greater than equals to 0. Condition is true, that is 15 is more than greater than 0 is equals to 0. Then simply printf, that is %c si, that is here it is s15. I means 15, that is s15. Then again to this, go to this one. There is a I minus minus, that is I becomes 14. If the I is 14, that means 14 is greater than equals to 0. Condition is also true. Then there is a percentage C, then SI, that is a S14. That is at the 14th location it is also printed. Suppose my enter it or my content is the hello. So there are 5 characters HELLO. So first of all it is print, or if I do this into the 5, for example, if I precise to 5, first of all the O will be printed, that is O will be printed. Then at the 4th location there is a L, the L will be printed. At the 3rd location there is again the L also printed. Then at the 2nd location the E will be printed, the E will be printed. In the 1st location the H will be printed, so the H will be printed. So the output is displayed by using the getCH function. This is the function that is used to simply reverse the string. The main crux is that simply uses the for loop, that is the reverse of the for loop, starting with the highest value, ending with the lowest value, I minus minus, and printf using the percentage C, and character by character it will print. So if I execute this code and if I use hello, the output is OLLEH, that is the correct output. So this is the case how we can build it, how we can use it. Right. So this is the program for reversing a string. Right. Now, if there is any doubt, then please tell the doubts. What is the doubt of the Larry? Sir, when we are starting practical approach on C programs, if this program is clear to you, Larry? Hello? Yeah, this program is okay. Okay, and your your question is on how when we are able to trying, or if we are able to start the Windows programming. So the answer is the Windows programming approach is little bit different, and this is not highest importance, but the highest importance is that on the DOS programming, that is how to do the for loop, how to use the while loop, how to use the array pointer. So we have left with all these contents, all these practical approach. I agree, we have studied with the theoretical approach, but we have left with the practical approach. So first of all, let's finish with this approach, that is the C programming with the DOS, that is how to use the for loop, while loop, uh, syntax is available, string, arrays, pointers, function. Then moves to the next part, that is the Windows programming, because that is not of highest importance. What is important is that this DOS programming, because these loops are available in each and every programming. Either you can use Java, either you can use C++. So please focus on this one. Then after this one I will move to the Windows programming for sure. But first of all finish this one, and please understand this one. This is the most important as compared to the Windows programming. That is important, but that is not as important as it is the Windows programming. All right. So let's stop over here only. All right. So let's stop over here only. If there is any doubt, you can clarify the doubt. Otherwise, I will finish the class, and in the next class, I'll be starting with this content, that is how to interact with the hardware, how the accelerated communication is done with the hardware. This is the program, or this is the diagram that we are going to discuss in this chapter. That is how to do the hardware interaction. Right. So let's stop over here only. Thanks a lot for today's session. If there is any doubt, then you can text the doubt. Thanks a lot. Bye bye everyone.